Hello, this is Mrs. Taylor, and I am going to review how to identify different properties of quadratic functions. So this is from an assignment we did in class. You may recognize this problem. On this particular problem, they gave you the graph of the parabola, the quadratic. It's the function f of x equals x squared plus 6x, and they want you to identify these different properties based on the graph. So to start with, domain, that's your x values, and that's your input. And if you look at this curve, it has arrows on the left and the right ends of the parabola. What that means is that this is going to continue moving infinitely up and to the left, infinitely up and to the right. So that means that there's no limitation on your inputs. I can input any x value I want and get an output. So my domain has no limit. So we can describe that two ways. We can say all real numbers, or we can use function notation, which is negative infinity to infinity. Either way you want to communicate that the x values are not limited is okay. You can write out the phrase all real numbers. You can do interval notation, negative infinity to infinity. Either is acceptable. Range, that's your y values. And if you look at this parabola, it continues infinitely upward. However, it has a minimum y value, and that minimum y value is here at -9. So you can think of this as this parabola starts at -9 and continues upward. So the way we can communicate that is we can use an inequality. We can say that y is going to be greater than or equal to -9. That communicates it's at -9 and upward. You could also use interval notation as well. It would look like in inequality form y is greater than or equal to -9, or you could say the bottom value is -9. It continues infinitely upward. We haven't done a lot of work with interval notation, but I try to throw it in there as much as I can just to familiarize you with it. One little detail, it is equal to -9, so when you use interval notation and you want to say that that value is included, you actually use a bracket. So again, just a little detail, nothing to stress over. We don't use interval notation a lot in class, but I just want you to see it when it's applicable. Alright, so y-intercept, we've been doing y-intercept for a while. That's where the line crosses the y-axis. So if we look at our graph, it crosses the y-axis at this point, and that is at the y value of 0. And we want to write that in coordinate form, 0, 0. It's a really weird font, so let me just change that right quick. Okay, so our y-intercept is at 0, 0. The x-intercept, that is where the curve crosses the x-axis. So here's our x-axis. It crosses at that same point that it crossed the y-axis, but it also crosses the x-axis here. So there's actually two x-intercepts. We have one at 0, 0, but we also have one over here at -6. So we'll just list our two intercepts. Now, many of you had questions about, on the benchmark, you saw that it said zeros, and this is where you've seen that before. We've talked about that zeros are x-intercepts. It's the same thing. They're synonyms. Just depending on what textbook or test you're taking, you could see one or the other. So they mean the same thing. Where does it cross the x-axis? The axis of symmetry, that is the vertical line that divides the parabola into two symmetric halves. So your axis of symmetry travels through your vertex. So that's here. Most of you, if I asked you to draw an axis of symmetry, you would be fine. You would know that it just cut your parabola in half. However, you also have to provide it as an equation. So it's very straightforward. All you have to do is write x equals whatever the x value is, and the x value here is -3. So you would say x equals -3. And that's how you communicate what the axis of symmetry is in your answer. That's how you identify it, by the x value. And it's the same x value of the vertex, which is the next thing they want you to identify. So I would have the vertex at -3. That's your x value. Our vertex is down here. It's this low point, this turning point of my parabola. And its coordinates are -3. That's the x value. And then we already know that the y value is -9 from our range. So -9. And that would be the coordinates of my vertex. The vertex is that turning point. Intervals of increase and decrease. So if I asked you to highlight the part of the graph that increases, what you would do is you would start on the left. We read a graph just like we read a sentence, from left to right. So I start on the left side of my curve, and I'm going down. That's a decrease, but then once I get to that vertex, it begins to move upward, which is your increase. So on this half of my parabola, I'm increasing. The decreasing half, that would be this left half here. So we have to figure out how we communicate left half, right half. Well, we do that with inequalities, because when they ask us for an interval, they're asking you what's the domain of that section of the graph. And so if you think about it, this axis of symmetry cuts the cuts the parabola in half. And anything to the right for this parabola is increasing. And to the right means greater than, because all the x values to the right are greater than that -3. So the way we write that is we say x is greater than -3. And that communicates that we understand that starting at the axis of symmetry and moving to the right, this curve is going to increase. Now, to the left would be the opposite. Instead of x is greater than, x is less than -3. So that is how we communicate that the left half of the graph is the decreasing half. Remember, you're starting on the left, moving to the right to figure out your increase and decrease. So this is a parabola that's opening upward. If we flipped it, and the way we know it flipped just by looking at the equation is the fact that the a value, this x squared term, is negative. So without even looking at the graph, I can anticipate that it is going to be opening downward. Domain is the same. There is no limit to my x values, so I can just copy and paste my all real numbers for my domain. Now, my range for this has a high value. That is at y equals +9. And then my graph is below that. So instead of y being greater than, it's going to be less than, because it's below that value. So we'd say y is less than or equal to 9. And that communicates that I understand that its highest point is 9. Every y value is less than that. Y-intercepts, that's where it crosses the y-axis, and I see if I follow the y-axis, it crosses here at y equals 8. Remember, we want to write these as coordinates, so 0, 8. My x-intercepts, where it crosses the x-axis, so I have 2. I have one at -2 and one at +4. So I would list those as coordinate pairs, -2, 0, and then 4, 0. And that would be my two x-intercepts, or zeros. And my axis of symmetry is that vertical line that cuts my parabola in half, travels through the vertex. And remember, our answer for that has to be an equation. X equals, and then whatever the x value of the vertex is, which is 1. Now, by this time, I've done all the work I need to give my vertex because I know it's at x equals 1 and at y equals 9. So I just put that together for my coordinates of my vertex. And just a note, when the parabola opens upward, this is a minimum value for the vertex. So the -9 is the minimum value that that function could have. And so if it's open downward, your a is negative, that means you're going to have a maximum. Just a side note. Okay, interval of increase. So if I start on the left side of my graph and read left to right, this first section is increasing. So my interval of increase would be the x value of 1, anything to the left of that. So remember, left goes with less than. So x would be less than 1. That's how I identify the left half that is increasing. And then for decrease, I would just flip that inequality. X is greater than 1. So that was a really quick overview of what we did with properties of quadratics. I hope this helps you review what we did before the benchmark.